Alright guys, so we are going to talk about trigonometry today. So when we're dealing with trigonometry, we are using these things when we are dealing with right triangles. So anytime we have a right triangle, we can use any of these what are called trig ratios. So we have three trig ratios. We have what's called the sine of an angle, and it's abbreviated SIN. We have what's called the cosine of an angle x. Then we have what's called the tangent of an angle x. So all of these, this one just means sine of x, that one just means cosine of x, that just means tangent of x. And x is going to represent an angle. So one way that we can remember this is with a little acronym, and that acronym is SOHCAHTOA. So we have SOH, CAH, and TOA. And we'll talk about what each of those means here in just a second. So when we have an angle, when we have a right triangle, we have three sides for that right triangle. So we're looking at a particular angle. Now, when we're looking at this angle here, so we have that angle x, we have three sides, and we call them three different things. So the side that is opposite the angle, so in this case it would be right here, that is called the opposite side. The side that is not the slanted side, that is next to the angle, is called your adjacent side. So this side right here would be considered our adjacent side. And then we have this slanted side, and that slanted side is always called your hypotenuse. So we've got our opposite side, our adjacent side, and our hypotenuse. So the sine of the angle x can be calculated by taking the ratio of the opposite side divided by the hypotenuse. So that's where the SOH comes from in SOHCAHTOA. So we have SOH. So sine is the opposite divided by the hypotenuse. Cosine then is our adjacent side divided by our hypotenuse. That's where the A and the H come from. And then tangent of the angle x is opposite divided by adjacent. And that's where the OA comes from. So when we start using these a little bit more, these three ratios are going to be very important. And in order to help you remember this, we can use this acronym SOHCAHTOA. SOHCAHTOA. All right, so in looking at this particular problem here, we've got a right triangle, has side lengths A, B, and C, as shown below. And we're going to use those lengths to find the cosine of x, the tangent of x, and the sine of x. So these are going to be jumbled every time that you do these, so it's not always going to necessarily be in this specific order. So the first one we're going to look at is cosine of x. So our angle is right here. That's the angle that we're looking at. And the cosine can be found by taking the adjacent side. In this case, the adjacent side is A, and the hypotenuse, which is B. So it would be A over B in this case. So then we find the tangent of x. Tangent is the opposite side. So the opposite side is C. And the adjacent side, which is A. And then sine of x. Sine can be found by taking the opposite side, which is C, divided by the hypotenuse, which is B. So we have those three there. Now the order is going to be different every time that you do these, but we still use these three ratios. Now if our angle was on the other side, so if we were looking at this top angle here in the triangle, then the opposite and the adjacent sides would be different. So this would be our opposite side, and then that would be our adjacent side if we were looking at this angle as our x. So that's the first one. So if we move on now, we're going to actually use these to calculate some missing side lengths. So we're given an angle, and this time we're actually given an angle measurement. And we want to figure out the side length right here. We're missing x. And we want to use the hypotenuse to help us solve that. So we're going to think of our acronym, SOHCAHTOA. And we're going to use that acronym to help us figure out which of the three trig ratios we're going to use. So we have our angle, and from this angle we have our opposite side, and then we have our hypotenuse. So since we have opposite, so this is our opposite side, and this is our hypotenuse, since we have those two things, this is the trig ratio we're going to use because we're given the opposite side and the hypotenuse in this problem. So we're going to plug everything in. So we're going to use sine. And instead of putting x here, since we have an angle measurement, we're going to actually put that angle measurement in for where the x was before. So that says sine of 32. And then sine can be found by taking the opposite side, which in this case is x, divided by the hypotenuse, which is 7. So now we have this equation that we need to solve for x. So it's telling us that we need to figure out what x is, so we're trying to get x by itself. So to do that, we're going to multiply both sides by 7 to get the x by itself. Multiply by 7. So then those cancel out there. So then we have x equals 7 times sine of 32. And on your Alex calculator and on some of the calculators that you have on your own, there are sine, cosine, and tangent buttons that you can press. So you're going to enter this in exactly as it looks on the screen. So you're going to take 7 times the sine of 32, and 32 is what's going to go in the parentheses here because that's the angle measurement. And when we do that, we get x equals 3.709 and then a bunch of other numbers. The directions tell us to round to the nearest tenth, so that means x is actually just 3.7. So we can use these sine, cosine, and tangent ratios in order to find a missing side. Now one thing I do want to say, if we're looking at one like this, we're given the angle, we're given the opposite side this time, and we're missing the hypotenuse. So we're still going to use sine because it's opposite and hypotenuse. So this time we have sine of 37 equals 16 over x. Now this time x is in the denominator, and that's kind of a problem. If we're trying to solve for x, x can't be in the denominator. So what we actually need to do is multiply both sides by x first. If we multiply both sides by x, what happens here is the x's cancel out. And then so we have x times sine of 37 equals 16. And in order to get x by itself, we're going to divide both sides by the sine of 37. When we do that on this side, those two cancel out. And so then we just would punch this into the calculator. So we take 16 divided by the sine of 37. And this time x would be 26.6 if we were to round it. So you would just put this in exactly as it looks in the calculator. So you take 16 divided by sine of 37, and 37 would go in the parentheses. So you'll have two different cases that you could have where, like we had previously, where x is in the numerator. And then we also have where x is in the denominator. So either way, we should be able to solve ones like this. So the next type of problem that you could see is one where you're given a fancy picture, and you could have like a flagpole, you could have a building where the sun's up here, and we'll put a little smiley face on the sun. So the sun is above the horizon, and we want to find the length of the shadow that is made by the sun when it's shining on the building. So the building is going to have a shadow from the sun. And so this is pretty much exactly like what we just did, only now it's kind of a real world problem that we're looking at. So we're given the angle, we're given we're trying to find the adjacent side, and we're given the opposite side of that angle. So if we look at SOHCAHTOA, we're given the opposite side and we need to find the adjacent side to that angle. So this time we're going to actually use tangent. So we're taking tangent of the angle, which is 64 in this case, equals opposite over adjacent. We don't know the adjacent, so that's where our x goes. And so just like what we talked about on the last one, since x is in the denominator, we need to move that x over first. So then those cancel out, multiply by x. So then x times tangent of 64 equals 71. So then to get x by itself, divide by tangent of 64. Tangent of 64, divide that also by tangent of 64. Those cancel. So then when we punch that into our calculator, 71 divided by the tangent of 64, we get 34.6 when we round. So x equals 34.6. So that means that that shadow there is 34.6 feet long. So we can use those trig ratios in order to solve a real world problem like this as well. So those two problems that we just did were ones where we're missing the side length. So now we're going to look at one where we're given two side lengths and we need to find the angle measurement. So we're going to use the same exact concept. We're going to plug in what we know. Using SOHCAHTOA, we can figure out which of those three trig ratios we're going to use. So we have our angle. We don't know what the measurement is. That's what we're trying to find. And we're given the opposite side from that angle. And we're given the hypotenuse also. So we have the opposite and we have the hypotenuse. So this time we're going to use sine. So we have the sine of the angle. This time we don't know what the angle is, so that's where our x goes, equals the opposite over the hypotenuse. So we need to figure out what x is. So that means we need to get x by itself. So in looking at this, we're not going to just divide by sine, or we're not going to subtract sine or anything like that. Some of you may have noticed there's a little button there's three buttons on the calculator on Alex, and then some of you have it on your calculators also, that have those little -1 looking exponents there. That's called the arc sine, the arc cosine, and the arc tangent. And those things here are what's called the inverse of those trig functions. And if we take the inverse of the trig function, and so if we were to take the arc sine of that whole side, that whole left side of the equation there, what would actually happen is our sine and our arc sine would cancel out, and then we would just have x left. Now whatever we do on the left side, we also have to do on the right side. So we have to take the arc sine of the right side of that equation too. So on the left side, the sine and the arc sine cancel it out. And then x is going to be whatever the arc sine of 11 over 15 is. Now, just like before, you have that button on your calculator. So you can just punch the arc sine button of 11 divided by 15. And that's going to give you a number. So in this case, x is 47.8 0.1665, and then a bunch of other numbers. And again, we're supposed to round to the nearest tenth. So that means that this angle here is a 47.2 degree angle, which makes sense if we look at it. It looks like it's about 47.2 degrees if you were to actually look at it. So taking the arc sine of a sine cancels those two out. The same would work if we were using cosine, and the same would work if we were using tangent. So just taking the arc sine, arc cosine, or arc tangent of whichever function that we're using will undo that, and then that will get the x by itself. So let's look at one more like that, only this time it'll be kind of a real world application here. So we have a 15-foot ladder that's leaning on the side of a house. So the ladder here is at the top of the house, and it's 15 feet from the top of the ladder to the bottom of the ladder that touches the ground. So that means that our hypotenuse of this triangle that's made is going to be 15. And then the bottom of the ladder is 8 feet away from the side of the house. So we know that from the house to the end of the ladder is 8 feet. And we want to know the angle that is made from the ladder and the ground. So in looking at this again, so we need to think of our acronym here, SOHCAHTOA. SOHCAHTOA. And we want to figure out which one of these we're going to use. So again, we've got our angle here. We don't know what it is. We have the adjacent side to that angle, and we have the hypotenuse of that triangle. So in this case, since we have adjacent and hypotenuse, we're going to use cosine. So we have cosine of the angle, and we don't know what that angle is, so that's going to be where our x goes, equals the adjacent side divided by the hypotenuse. So that's 8 over 15. And so then we want to undo the cosine. So to do that, we're going to do the arc cosine. So we take the arc cosine of that side. And whatever we do on the left side, we also have to do on the right. So we take the arc cosine of that side. So then the cosine and the arc cosine cancel out, and we have x equals the arc cosine of 8 over 15. And then if we were to punch that into our calculator, we would get 57.769, and then a bunch of other numbers. And we're going to round to the nearest tenth of a degree again. So in this case, it would be 57.8 degrees. So those are all the trig topics that you can look at. After you finish the homework assignment on this, you can go ahead and look in your blue geometry slice and work on those topics after you finish this homework assignment. I hope this helps you guys, and if you have any questions as you're working, make sure that you let me know.